Hello there again. We've just looked at uh, how to measure water quality, and after measuring water quality, how to compare the water quality with the different standards made by different agencies like the WHO, then NSC's guidelines like Bhutan Water Quality Drinking Standards, um, Bhutan Ambient Water Quality Standards. So please try to look at those standards while you have already collected the values to just compare whether those standards are whether those samples are meeting the standards or not. Now let us look at water quantity and how to measure water quantity. This presentation will be just a repetition of the presentation that we just saw on surface water flow, how to measure surface water flow. We have looked at a surface water flow or the discharge, and we looked at four different methods to measure surface water flow. First one is bucket method, second one is water level change method, third one is water level drop method, and fourth one is V-notch method. So just a refreshment uh, for water flow, surface water flows technique. We'll just be looking at this again very shortly. So it's just going to be a repetition. So if you feel like you already know this technique, so please do not have to watch this presentation. If you feel that you again need to look at different kinds of surface water flow measurement techniques, then you need to look at. So one of the best methods and easiest method to measure the quantity of water is through container or bucket and stopwatch method. So let's say if this is a stream or spring or a small river system, and you basically can get this discharge through the opening of your bucket. So what you can do is you can lead one of your friends to look at the stopwatch and set the timer. Then as soon as both of you synchronize 1, 2, 3, then one synchronizes the time and the other gets the water filled inside the bucket, and that bucket quantity should be known, or the volume should be known. For example, 5-liter bucket, so the time should be set perfectly or correctly. It should be very precise, and if it takes around like 1 minute to fill up 5-liter bucket, then 5 liter per minute is your discharge time. So basically a discharge or a quantity is measured in terms of volume per time or quantity per time. So that's a very easy method. One is bucket method, just bucket here and time here, that's it. Second one is water level change method, where you need to have a tank or you need to have large a bucket or syntax that has got graduation scale, or if you do not have a graduation scale, that has got specific or known length and breadth and the height, so that you will basically know what is the change in height or change in volume after you receive spring. So what we are going to do is that we're going to have a tank with known volume, meaning known length, breadth and height. If you know length, breadth and height, then we obviously know the volume. So if there are some water in the tank, we first note the water level before spring discharge, or like before any stream was flowing into this one. So so we just note that this is the level. Then we go up and we see that spring water or the stream has come into this one. So we basically note down the change. So if this water has reached this much, then what is the change in volume from the previous one? So this change or this displacement can be the quantity from that, or quantity of the discharge from that river or stream. So you can measure in the time taken to reach this much of quantity or this much of volume is your water quantity or water discharge. That's with the water level change method. And this is the explanation. You can read yourself. Other one is the drop method. So what we are going to do is, we do not need, unlike this one, where you exactly need the a known volume of the tank or the storage equipment. But in case of this one, you do not need any known volume or tank, any kind of like structure that basically do not have any outflow. So please remember, it has no outflow, so it's quite tight. The water, once it comes inside that tank or that unknown irregular pond or tank shaped structure, it is not going back. So what we are going to do now is, the volume of this is not known, so it's okay, completely okay. But we are going to take out one bucket of water out and throw it here, and we are going to look at the measurement where, after taking out the one bucket of water, where it had this new level of water has gone down. So after taking one bucket of water, let's say this is 5 liter of water, then this is the level of change that we saw. Now try to connect the stream or spring or the river to this one, and try to note the initial and the final reading. So this was the initial reading of the water level before taking out the bucket, before taking a bucket full of water. And this is the second level or the final level of water after taking out one bucket full of water. Then try to connect with a stream or river or any surface water that you want to connect. So that moment that it has reached up here after connection, it's the moment that it has reached 5 liter, and note down the time. 5 liter per, if it is taking like around 3 minutes, 5 liter per 3 minutes, so that's around 1.7 per minute. So try to calculate 1.7 liters per minute. So that's the discharge, that's the water quantity that that stream or that river that you just connected has. So that's the second water level drop method. You're basically dropping the level. The third one is that what we generally call as V notch, because we are making a notch that is about perpendicular to each other. And what we are going to do over here is that we basically have some readings. So if you see, there are some readings over here, these are some readings, so there are readings over here too. So we're going to construct a perfectly 90-degree angled V, whereby we will let, after construction, we will place that towards the mouth of the river or towards the mouth of the stream. Then after that, we are going to note down the height at which that river or stream has reached. So after noting the height is basically going to give us the quantity of water that flows in that stream or river. So if the height is just 1 centimeter, let's say the height is just 1 centimeter here, this is just 1 centimeter, this is 2, this is 3. If the height is just 1 centimeter, then we have 0.88 liter per minute is the quantity of water that is flowing from there. If the height is 4, we have 1, 2, 3, 4. If it is reaching around here, if the water is coming out from here, then the quantity of water that's flowing from that river is 28.28. If the height is around 18, that's around like 1213.62 liters per minute. So that's it about how to calculate through V notch. And the calculating of discharge or quantity of water is quite easy, provided the river system is small that you can handle, or the streams are quite small that you can handle. But if the river very big and all, then you have got other methods to do that. NCHM, National Center for Hydrology and Meteorology, takes care of water discharge across the country. So it really looks at what is the water that's being going through that river bed. If even if the river is quite huge, even if the river is quite big, it generally looks at the volume. If you have seen some of the hydromet stations where they have got water depth scales placed near the bridges, so that's basically to calculate water volume, water level changes during the seasons and all. That will again basically give you idea of what is water quantity and what is water discharge all about. But they usually do this through computer aided modeling, where they look at the water as some kind of like a system input into their computers, and from there they generally take out results, specifically the water quantity at that time. So it's based on modeling. So during your internship, or if you have some of the people visiting from NCHM to the college, I'll definitely like to have them as one of the people to teach you how to model out the water quantity, specifically looking water quantity at big rivers and big dams. So small rivers and streams can be done through this 4 different methods. That's all with water quality and quantity. I hope you understood something else from here. Thank you.